So hello everyone and welcome to yet another PTC Nordic Talk webinar session where we are happy today to having Darrsan Raveendran, CAD Product Application Engineer at PTC, for a session on how to start your digital thread journey with the latest in CAD design. But first, as always, a really quick introduction about myself. My name is Carl Jensen. I am the Customer Success Manager for PTC in the Nordics. And we're running this weekly webinar on Fridays, same time, where we invite customers and partners for inspiration on digital transformation to see what's possible and how to make things happen. And all the past webinars have been recorded and are to be found on our registration site. The agenda for today is the first quick overview of PTC by myself, and then Darrsan will start by introducing himself and touch base on the few challenges and how to address those and explain some of the outcomes. And at the end, we'll have the Q&A session, so please keep your questions to the end. So now about PTC. So PTC is an international software company with a headquarters based in Boston. We are developing software mainly for manufacturing companies since 1985. We offer tools for digital transformation, such as CAD for design, PLM for managing data, IoT for connecting products or manufacturing operations, and augmented reality to visualize and interact with the digital thread. Before I let Darrsan start, I just want to do a quick announcement. We plan to set up a CAD community for CAD users, Creo users, and I will let you know more about this in the coming sessions. To you, Darrsan.
Thanks, Carl. Hi, everyone. Apologies for the slight delay, some technical issues, but just a bit about myself. I'm here on the CAD technical side of things at PTC, and today's webinar, I guess, will be surrounding the latest in CAD design with Creo 9. So I'm just going to move on to my slides here. So Creo 9, it's a feature-packed release with tons and tons of improvements. I've only got a few minutes here, so I'll be covering these core topics today, and today's more of a general overview session, so I won't be going too in depth into these different areas, but I believe we will be having some more in-depth sessions maybe later on in these Nordics Talks calls. So we'll start off with some improvements we've made to core modeling in Creo 9. So we now have a new divide surfaces tool, which, as you can probably tell from the name, its functionality is to give users the ability to separate a surface into different regions based on a sketch. Now, we can then use these surfaces as semantic references. Now, it's a pretty simple to understand tool, but it actually brings a lot of extra capability to some of our other areas in Creo, like simulation and generative design, where you can now apply loads and constraints on individual defined areas thanks to divide surfaces. Model-based definition is another area that benefits from divide surfaces, as well as streamlining the workflow to create geometry modifications and assigning appearances. Now, we also have a unify surfaces tool, which does the exact inverse of divide surfaces. So unify surfaces allows users to recombine any divided surfaces back together. So I'm going to jump into a demonstration here. So you can see I've got this part here in Creo, and what I'm going to do is demonstrate the divide and unify surfaces feature. So I'll just enable zoom it here so I can highlight things better. So you can access the divide surfaces tool in our editing tab in Creo. So in our split drop-down menu, you can see I've got a divide surface tool there. And this time it's asking me what surface do I want to divide, and I'm going to select this surface, and I'm going to select the sketch I've already made. So I'm going to select sketch 8, which is simply Creo text sketch. So I'll just try this again. So sketch 9, sorry. So there we go. So you can see I've already had this sketch prepared. So it's just Creo text sketch, and you can see divide surface is already dividing that surface into 2 different regions. And once I hit OK, you can see that that divided surface region has a new surface ID of F92. And this is what I was talking about here. This new surface ID allows us to perform expanded capability in Creo, one of those areas was flexible modeling. So I can now create engravings and extrusions much quicker, just like this. So I can create some sort of engraving just like that. And I also mentioned unify surfaces was something else we're introducing. So if I just go back in my model tree history, I can go into unify surfaces, which is located just below our split drop-down menu where we accessed divide surfaces. So once I hit unify surfaces, I can select those two surface regions. And just like that, I've already recombined that surface, which I divided into the original surface, which I had before. So that's divide and unify surfaces in Creo 9. We've also made some additional improvements to our core modeling capabilities in Creo 9, starting off with some Sketcher environment improvements. We now have something called Autoscale First Sketch. Now, this is something that allows users to preserve the geometry of any sort of sketches that they might have had. So in Creo 8 and prior versions, whenever our users wanted to make a change to the initial dimensions of any sketch, the aspect ratio of the sketch would tend to go all haywire, which means that they wouldn't have been able to preserve that original geometry they had. But now, thanks to Autoscale First Sketch, whenever a user makes a change to any initial dimension, all of the other dimensions in that sketch will also scale up or scale down by the exact amount we scaled that initial dimension by. We also now have some new modernized and more intuitive user interfaces for our project and offset tools, which allows for better handling and management of references like edges. And we've also got some new enhanced and enriched inspection tools, like the ability to now highlight overlapping geometry much easier, as well as the ability to highlight any intersections and junctions. We also have a new functionality in Creo 9 to create geodesic curves. So geodesic curves are simply curves between 2 points that is the shortest possible distance. And we can now create these geodesic curves from a starting point and also specify the angular direction of this curve. And we've also enhanced the flexibility of our patterning features in Creo 9. So now we can change the hole type directly within a dimension pattern without having to remove that dimension pattern and then repattern that hole. Now, we're also introducing an identical regeneration option for a geometry pattern, which means that we will have much faster regeneration times in Creo 9. So I'm going to jump into a quick demonstration just to show how quick these regeneration times are. So I've got this simple cooling cover part here, and you can see I've already created a whole feature here. And what I'm going to do is I'm going to create a geometry pattern feature of that hole. So you can see a geometry pattern creates a copy geometry of that hole. And what I'm going to do here is I'm going to go for fill pattern, select hole 2. So I'll select sketch 2, give it a border of around 3 millimeters. And you can see right now I've got a general regeneration option for my geometry pattern, which means that Creo is having to calculate the geometry of all of these instances. This means that, as you're about to see here, it can take a considerable amount of time to regenerate just because there's a lot of calculation work for Creo to do. But what I'm going to do here is I'm going to cancel that regeneration and I'm going to redefine my geometry pattern feature. And this time I'm going to switch the regeneration option to identical, which means that Creo makes several assumptions and there's much less calculation work for Creo to do. And now in Creo 9, you can see the regeneration times are much faster. That literally took about a second to remove all of that geometry. So I think it's very impressive in Creo 9. So moving on to additive manufacturing, a very interesting area where we have made considerable improvements in. So with additive manufacturing, we now support the ability to generate stochastic lattices on open quotes and individual surfaces. So before in Creo 8 and prior versions, you would be limited to just using bodies to generate these stochastic lattices, but now in Creo 9, you can use open quotes and individual surfaces to generate these stochastic lattices. We've also improved the regeneration algorithm for these stochastic lattices. So before in Creo 8 and prior versions, whenever our users had very, very complex stochastic lattice geometry, these stochastic lattices would tend to fail, but that's no longer the case with Creo 9. And something that's very interesting that we're introducing in Creo 9 is automatic variable wall offsets for formula-based lattices like gyroids. So this is the ability where users can now automatically generate these things known as baffles, which is extremely practical for things like heat exchangers and mixers, as baffles allow you to have better control of your fluid flow within a formula-based lattice. So let's take a look at this baffle generation with an example I've got here. So this is a very simple heat exchanger part that I've created here. And in my bodies here, you can see I've got the conventional shell body, and I'm just going to hide this. So we can take a look at these two different complementary bodies that each represent their own individual fluid domain. So for my green fluid domain, I might have fluid flow entering via this inlet here, working its way through this lattice here, and solely exiting via that outlet there. Same for my red fluid domain. I've got fluid flow coming in through that inlet there, working its way through there and solely exiting via that outlet reserved for that individual fluid domain. So I've got exclusive fluid flow paths. And the way I'm doing this here is I've created a lattice feature here. And if I go into my density options, you can see I have a new option in Creo 9 called variability of wall offset, aka the ability to create baffles automatically in Creo 9. And this is extremely practical for things like heat exchangers and mixers, where we're now achieving exclusive fluid flow paths without creating any sort of additional geometry to achieve this. We're doing this by using baffle generation, where we're propagating that lattice geometry, as you can see here, from our references. And this allows us to save a lot of material usage, which means we're not only saving a lot of cost, but we're also minimizing the weight of these heat exchangers and mixers. So whilst we're on the topic of additive manufacturing, users can now also create their own user-defined support structures in the 3D printing assembly environment. So before you had to solely rely on the materialized technology to automatically generate supports, but now you can create your own as well. So moving on to Creo Simulation Live. For those of you who might be new to Creo Simulation Live is PTC's offering in partnership with ANSYS as a tool for engineers to provide real-time simulation feedback. And in Creo 9, we're making several improvements to this tool, such as the ability now for multiphysics simulation. So now you can combine both stress and thermal attributes like I don't know, fixed constraints and maybe heat loads together in a simulation study. And in Creo version 9.0.1, we now also have support for contacts in Creo Simulation Live. And something that I showed previously with lattices is actually reinforced by this new ability with Creo Simulation Live, which supports lattice geometry for fluid flow simulations. So let's take a look at that latest feature here. So since I'm on the topic of lattices, I'm just going to use the part that I showed previously. So I'm going to jump into Creo Simulation Live, which is located on that tab here called Live Simulation. And if I just wait for this to load, we can see that I've already set up two different simulation studies, which each represent their own individual fluid domain. And you can see that I've already set up my flow velocity and my outlet pressure. So what I can do now is hit simulate, and you can see this is the beauty of Creo Simulation Live. It doesn't take ages and ages just to visualize your simulation results. It takes a matter of seconds as it harnesses the power of my GPU. And just like that, I'm viewing results, and you can see how Creo Simulation Live in Creo 9 now accounts for that internal lattice geometry. And I think this also represents how powerful Creo Simulation Live now is, despite it not being a high-end simulation package like ANSYS and Creo Simulate. So I'm going to jump into the next topic. So generative design. again, for those of you who might be new to generative design is our offering of a tool where you can harness the power of artificial intelligence to automatically generate a design based on parameters which you as the user get to define. And in Creo 9, we now have I believe we've actually made considerable improvements in Creo 9 to generative design, as we now have a new design goal in our design criteria where you can tell generative design to drive the mass of any design down to the minimum that's possible, whilst also according to a safety factor that you get to specify. And before in Creo 8 and prior versions, we only had structural studies, but now we've also got modal studies where you can maximize the fundamental frequency, or you can minimize the mass at a fundamental frequency floor. We also now have a ball constraint, which is useful for any sort of spherical surfaces you might have where you want to fix the translation but keep the rotation free. And finally, we also have this new initial simulation capability where you can quickly visualize the simulation data even before you send that study off for the optimization. So we save a lot of time in that process. So I'm going to jump into a model here. So I've got this part here, and in order to access generative design, it's located in our engineering tab, in our applications tab. And you can see that my study is not defined right now. And the reason for that is because I haven't specified all of the parameters that I need to. So here, what I'm going to do is I'm going to assign a load at that defined area, thanks to divide surfaces, which is one of the features I mentioned is new to Creo 9. I'll give it a value of 2,700 newtons. And you can see my study is still undefined. And the reason for that is because I haven't specified a design criteria. And this is the old design criteria goal I had, maximizing the stiffness at a volume or mass that you set. The new design goal, which is to minimize the mass and to specify a safety factor, is what you see here. So you can see that it's going to drive the mass of this part down to as much as possible to a safety factor that I'm going to set, which in this case is going to be 1.6. And you also have various manufacturing and geometry constraints here, which you can specify. And what I'm going to do here is I'm going to use a parting line constraint. And the reason I'm using this constraint is because this part here is actually going to be manufactured using a traditional casting method. And I'm happy with an aluminium material. And now you can see I get a notification saying this study is fully defined. So now I can hit optimize, and I won't do this now because it does take a couple of seconds. But I also have this new option, which I mentioned, called Run Initial Simulation. And this allows me to quickly visualize simulation data. And you can see it took a matter of seconds. And if I hit Display Simulation Results, just like that, I get simulation data before I send something off to optimize. And this tells me if the goals that I had before were even realistic to achieve. So if you remember, I had a safety factor goal of 1.6, but initial simulation is telling me, okay, that's realistic to achieve because the maximum possible safety factor here is 2.52. So now if I do hit optimize, I'm actually going to switch over to another part here just to show the optimized result. So once again, I'll jump into generative design and I'll wait for this to load in that optimization data so we can take a look at what generative design has actually created. And once this loads in, we should see a very organic looking shape, something I otherwise wouldn't have been able to create by myself. And we can look at the final simulation results, and we can also animate this if we want, just like this. So you can see how that's deforming because of those loads I've applied. I can also look at the safety factor here, and you can see I've achieved a safety factor of 1.75. So generative design has actually done better job than I expected. So I told it a target of 1.6 for the safety factor, but you can see here it's actually done a better job. So great job, generative design. And that's generative design in Creo 9. So I'm just going to move on to the final topic since I believe we're running short on time, which is subtractive manufacturing. So in Creo 9, we now have various improvements to our subtractive manufacturing manufacturing capabilities, starting off with a geodesic 5-axis finishing toolpath. Now, this complements our high-speed milling roughing sequences that we had in Creo 8 previously really well, because what this geodesic 5-axis finishing sequence allows us to do is it gives us a very, very nice surface finish. And on top of that, we've now got associative in-process stock models, which are something that you can now directly reference within Creo Parametric without having to rely on an STL file. And finally, we now have a new adaptive feed parameter for any high-speed milling sequence, where Creo will now automatically adjust the feed rate depending on the level of tool engagement. So if you've got your tool going around a corner, Creo will automatically scale down the feed rate because it doesn't need to be that high. And this not only results in faster overall machining, but it also avoids chatter and it increases the overall tool life. So I've got a quick video here in the interest of time, where we show off the geodesic finishing capabilities. I'm going to skip here where I finish all the settings. And if I hit play simulation here, we can see what a really nice surface finish we actually end up with thanks to geodesic finishing using 5-axis capability. So we're not limited to working with 3-axis. We actually get to work with 5-axis here. And you can see that thanks to the geodesic algorithm which we've implemented here, the axis control is automatically handled by that algorithm depending on your tool cutting direction. And yeah, you can see what a nice surface finish I get. So that's all I wanted to cover today. Like I mentioned, this was a more of an overview session into various areas where we've made improvements in Creo 9. I believe there was a plan to do more in-depth sessions covering these tools in greater detail. Sorry, these areas in greater detail. So does anyone have any questions on what I covered today?
Thanks a lot, Darrsan, for sharing all your interesting updates and cool demos. So now over to the audience for the Q&A session. If any one of you has a question, please ask Darrsan. If there is no question yet, I'll start with the first question to you, Darrsan.
Sure.
So, question: what is the biggest challenges when implementing those new CAD features in various organizations that you have come across?
I feel like the biggest challenge would be understanding the capability and how well it actually translates to your requirements, because every single customer or user has a different requirement that they want to achieve. And I think the biggest challenge is just understanding how these capabilities actually relate to what you're trying to achieve. And I think the best way to get around that challenge is obviously for our customers and users on this call as well to just give this a try in Creo 9. And I think that is the best way for any customer or user just to see how well this new capability works for them.
Good answer. Thanks.
Thank you.
Anyone else in the audience? Otherwise, I'll have another question.
Sure.
Really, who should be involved in the discussion on bringing in new tools such as the ones you have shown into an organization?
I think that's a very good question, Carl. And I think my answer to that would be purely the engineers that are using the tool, because at the end of the day, they are the people who will be spending the most time with the tool. I think they understand the requirements of what they're trying to achieve as well as the tool's capability the best. But I also think it's important that various stakeholders within the company also get involved with that decision, because at the end of the day, you would find in various companies that these stakeholders do specify the requirements that these design engineers have to work with. So I think that would be my answers, both the design engineers who are using Creo and also the stakeholders who specify the requirements that everyone has to meet.
Makes sense. Great. The audience, any question? It's a bit quiet today.
Yeah, there was a lot cover.
It's a lot of, yeah, there's a lot of information to digest.
Yeah.
But as mentioned, there will be more sessions, more in-depth sessions on the various topics we've touched on today. But if there's no other question, I'll have one more question to you, Darrsan,
Sure.
because I'm curious to
Absolutely.
know, yeah, how mature are companies that are using Creo in terms of, you know, those new features? Do you see those features being implemented quickly, or do people need to test and, you know, decide on if it makes sense for them to implement? Because it seems very interesting technologies for really predicting behaviors in the models. So I'm just wondering how quick are companies to adopt, and what's the maturity level in the CAD usability?
Again, great question, Carl. I think in terms of maturability of some of the features I've shown here in Creo 9, there is certainly a transition period which a lot of our users and customers tend to experience whenever we release a new version like this. So with all of these new capabilities in Creo 9, we often don't see these features being used straight away, but it's more of a long-term benefit with these features. It's something that companies can confidently rely on for the long term, that they can access these features whenever they want, whether it's a couple of weeks or whether it's a couple of months. And I have switched back to this generative design slide just purely because I'd like to mention an example. So Jacobs Engineering, they're a massive contractor for NASA, and we've worked with Jacobs Engineering specifically on generative design all the way back in the Creo 7 days. And Jacobs Engineering, they produce astronaut space suit equipment for NASA, and they used generative design back in Creo 7. And Creo 7 was when we actually introduced generative design, so it was still quite in the early stages of its maturity, and they had to use our cloud environment to get a safety factor value. But now I think Jacobs Engineering would really value this new safety factor target feature, and I think they will immediately update to Creo 9 just purely because of the safety factor target meeting some of the requirements they had before. And I guess in Creo 7 they had some limitations around safety factor.
Great, thank you. That's a good answer.
Sure.
One last question. Time is almost up.
Yeah.
From Jun Tian. While optimizing the topology of the parts, how do you handle the manufacturability, for example, the tolerance and/or machine cost of these features in the design phase?
So great question. So with the tolerances, it is all set within the design criteria. So it's something we can't change throughout the optimization. It's something you have to specify before running the optimization. And I think this does represent uh, one of the aspects about generative design that we still need to understand. It is a tool where we let artificial intelligence do most of the work for us, especially with tolerances. So we don't necessarily have that capability to influence the tolerances and manufacturing conditions throughout an optimization. We have to set that before we even send it off to the topology optimization solver.
Great. Thank you so much for that answer.
Sure.
So that's it. Time's up. So unfortunately, we're running out of time. So thanks everyone for joining this session, and special thanks to Darrsan for this great presentation. And as
Sure.
said, we will have more on that coming in the next weeks. So with that said, I wish you all a fantastic weekend and hope to see you again at the next webinar next week. Have a great weekend, everybody, and thanks to you, Darrsan.